Now let's start our next topic, that is checksum. Previously we did a study about the parity checks, and we studied that how we find the exact bit that has got changed in our parity blocks. And this is how in our previous examples this is how we found out that this row number and this column number is has the error. That is basically the error position. This is how we have measured it, and this was our error bit. Now we are going for the checksum. Checksum is another way of error checking. Let's see how it works. Data is sent in blocks. Extra value checksum is added. Calculated using agreed algorithm between the sender and the receiver. Sender calculates checksum, sends it with data. Receiver recalculates that checksum with the same algorithm, and then when the both values are compared, if they are same, then there is no error. But if the value is different at the receiver's end, then of course request has to be resent. Just see how we do the. Let's see one of the algorithms of the checksum. Checksum computes a sum of data bytes and sends it along with the message. The receiver recalculates the sum and compares it to the received checksum. For example, we are sending 2 bytes and 2 bytes of data, and the first is byte is 10101100. Second is 11001010. When we calculate their checksum, we add these values, we get another 9-digit value. So the leftmost value is the carry bit, so we discard it, we truncate it, we discard it because it is a ninth bit. So we only consider the 8 bits as a checksum value. So when it reaches the receipt to the receiver's end, he must calculate the same checksum. If his answer is also same by truncating the carry, then obviously there is no error in the data. Now there is another thing that is called echo check. In echo check, how we do, sender sends data to the receiver and receiver sends back the exact data. And if sender receives the exact data, this means uh, that there is no error. If the original data is echoed and or if it doesn't match, then it means obviously an error. There is an example. Sender sends message hello and receiver receives a message hello. So this means if the receiver is receiving the message hello and receiver sends the message back and that message is again hello, then obviously there is an error in the message. So sender detects error and resends the data. So because it compares it with the previously sent data. Now echo check, let's see, repeat it. Data is sent, then returned to sender. Sender compares original data and the returned data. If they are same, then no error. If they are different, then obviously there is an error. Limitation: we cannot determine where error occurred. We cannot find the exact position of the error in echo check. Next is check digits. Let's first compare the parity checks, checksum and echo check. Let's see about the parity check method. It has a strength that it is very simple and easy to implement for the programmers. And the weakness is that it can only detect single bit errors, not multiple bit errors. That was the problem with the parity check. It hasn't mentioned the parity blocks here. Next is checksum. Checksum is more reliable and it can detect multiple bit errors as well. But it cannot detect all types of errors. If data changes in a way that keeps the sum the same, then obviously it won't be able to detect the error. And echo check, it is simple and works well for small messages. But if both the original message and the echoed message are corrupted in the same way, errors may go undetected. Okay, that is basically echo check, in which receiver resends the data. And if both original data and the echoed data are corrupted, if both are corrupted, then obviously there is no way to detect the error. Next is our check digits. Let's see, read the check digits a little. An extra digit is added at the end of our code and calculated from other digits. it is used in barcodes, ISBN numbers, vehicle identification numbers. There is an extra digit. So we use some algorithm for it. A check digit is the final digit in a code. It is calculated from all the other digits in the code. Check digits are used in barcodes on products, ISBN, International Standard Book Number, VIN, Vehicle Identification Number. They are used to detect errors in data entry caused by incorrect digit entry. Users who assign the IDs, they may do some incorrect basically you can say incorrect character or incorrect number. So in order to find that out, we use this basically check digit method. Transposition errors, there are 5037 instead of 5307, there that is also possible. Incorrect digit error, 5327 instead of 5307. And we have omitted or extra digits. For example, we there is a 537 instead of 5307 or 53107 x instead of 5307. It means that a digit may be omitted or extra digit may be added instead of the original number. So we use the ISBN code for that. It includes a check digit at the end, which is used to verify correctness of the entire number. Suppose this is our number. This is 97803409838 and then there is at the end there is a check digit. And so check digit in the ISBN number there is written at the end. This is 9 is our check digit, and we can verify whether it is a correct check digit or incorrect. There are methods for generating check digit and also the method for verifying the check digit. We will first go for the ISBN-13 method. ISBN-13 code includes a check digit at the end which is used to verify correctness of the entire number. The better pronunciation for this ISBN-13 is basically what you should say. You should call it ISBN-13. Why? We are coming to that. How we use ISBN-13 method. Suppose this is our number, and now we are going our number, and we imagine that we haven't generated the check digit yet. This is our only number. What we do, we separate our digits like this. This is how we have done it them in the separate columns. Now, this is ISBN 13. We multiply the odd numbers, odd positions by 1 and multiply the even positions by 3. You can say 9 multiplied by 1, that gives the result 9, and 7 is at the second position, so obviously 2 is the even position, that is multiplying by 3, that gives us 21. Again 8 is at odd position, 8 will be multiplied by 1 and it gives us 8. 0 is at even position, so obviously it will be multiplied by 3 and that gives us the result 0. Then again 3 is also at odd position, as 1, 8 is at 3 and this 3 is at 5 position, this 0 is at 7 position, this 8 is at 9 position, this 8 is at 11 position. So all these numbers are odd numbers. So and let's talk about 7. It is at 2 second position, and then we have 0 is at 4 position, this 4 is at 6 position, that is also even, this is 9 is at 8 position even, 3 is at 10th position, 2 is at 12th position, they are even positions. So you can see all even positions are multiplying by 3 and these are the results we are getting. Now we are calculating the sum of these results that is coming by multiplying these values. 9 plus 21 plus 8 plus 3 plus 12 and all of that is giving us the sum 111. Now we have to generate a single digit. In order to generate a single digit, what we do, we divide the number by 10 and get the remainder as a check digit. How? Let's see. We have divided 111 by 10. What we get? We get 10 multiplied by 11, 110, and the remainder we get is 1. Once our remainder is 1, what we do, we subtract it from the from 10. This is how we get our check digit. What is the method? We add these values, divide by 10, get a remainder, and subtract the remainder from 10. Then we get the check digit. We divide by 10 because we have to generate a single digit. So our check digit 9 is generated and we have put it along with it. Now we have to verify it. How we verify it? Okay, this is the same thing. This is how it is done in the book. In the book, it has written all these methods, the entire method in the book example. But I think this method will be much easier to understand for all of everyone. Okay, and next, in the next, we have another thing, that is we are going to check this digit whether we have done it correctly or not. This is our check digit, that is 9, and these are our the digits of our number 9. So we have again, what we have done, we have again multiplied by them by the 1 and 3. Odd number positions are multiplied by 1, even number positions are multiplied by 3. So, and what we have done, we have just calculated their total result and including the check digit as well. We have included the check digit and we have multiplied it by 1, and so now we are adding all these numbers, we get the answer 120. Once we get the result as 120, if we divide it by 10, we get the remainder as 0. If the remainder is 0, because 120 is fully divisible by 10, uh, uh, that that quotient we get is 12 and the remainder we get is 0. So our check digit, it represents that our check digit is absolutely correct. If the remainder is 0, this means our check digit is correct. That's simple as that. Okay, we will go for the modulo 11. The modulo 11 example, this is a second method. The previous method is ISBN-13 and this is the second method, that is modulo 11. That is to generate a check digit. You have a number 4156710. Okay, this is our number 4156710. And how many digits are there? There are basically 7 digits in it. So you want to add extra digit, that is a check digit at the end, so that the whole number passes a test. How to create the check digit by using modulo 11? What we do, we first write down all these digits in the separate columns or boxes, and also we assign weight to all those digits. The leftmost digit we assign the weight. Suppose this is seven digit number, so we assign the weight as 8 to the first number. The second number, the weight is 7. Third number in the sequence, we assign all the weights 6, 5, 4, 3, 2 to the each position of the digits of the number. Now what we do, we multiply them. 4 multiplied by 8, 1 multiplied by 7, 5 multiplied by 6, and now when we calculate the sum, so the final calculated sum is 130. What we do, we divide it by 11. Once we divide it by 11, we get some remainder. Dividing 130 by 11, we get the remainder. 11 multiplied by 11 gives 121. So the remainder we get is 9. So check digit. Wait, there is some mistake. This line shouldn't be here. Check digit is correct. This is a mistake. So the remainder we are getting is 9. So let's, and what we do, we subtract the remainder we get from the number 11, and what we get, if the remainder, so the number we get, that is basically our check digit. So the check digit that will be added to the end of this number, that will be 2. So the final number will be like what? This will be our final number. Let me write it correctly. So what it means, uh, okay, so this number, this is our our final number with check digit. So that is how it's gonna work. I think everyone has got it. This one is also easier. Now let's see how to test the check digit. It's the same method. We assign the digit. Then we put the weights starting. If there are 7 digits, so obviously we use the 8 as the highest weight. So then 7, 6, 5, 4, 3, 2, 1. We will also consider the check digit in it because we have to verify whether the check digit is correct or not. Now, when we multiply them and we add them all, if we get the remainder 132, if we divide it by 11, if we get the remainder as 0, this means our check digit is 100% correct. That's all for this method. And this is how it is written in the book. And I think this approach is much easier to understand. And this is the approach that is written in the book. All the steps are written separately. The following algorithm generates a check digit from the other 7 digits. One each digit in the number is given a weight. How we start the weight? The total number of digits as 7, so we give the weight 8, 7, 6, 5, 4, 3, 2, starting from the left. The digit is multiplied by the weight and then the total is divided by 11. The remainder we is then subtracted from 11, the final check digit we get. And then we verify that by including the check digit in the multiplication. So these are our questions that are activity questions that will be solved by using the same methods that we did in that. That's all for this. We will also do this activity in our next lecture, inshallah. Thank you.